So you've probably heard the phrase, nothing lasts forever. But what if it could? What if you could build a machine that never stops? One that just keeps spinning, keeps working, without any fuel, without any wires. Just powered by the forces of nature, gravity and magnetism. Sounds like science fiction, right? Well, today we're going to dive deep into the fascinating and controversial world of perpetual energy and ask that big question. Could gravity and magnets give us free energy forever? Hey folks, welcome back to the open source ReThink. I'm Thren, your host, and I've been going down a bit of a rabbit hole lately. Or maybe a black hole, exploring the idea of perpetual motion. Now before anyone in the comments starts shouting, "But physics says it's impossible," let's slow down. I'm not claiming we've cracked it. I'm just fascinated by the possibility. And I want to walk you through the concepts and experiments and the wild ideas that people have had over the years. So, what exactly are we talking about? A perpetual motion machine is a device that once started keeps moving forever without any extra input or energy. In theory, it could power something endlessly. The problem is, it breaks two big laws of physics. The first law of thermodynamics tells us that energy can't be created or destroyed, while the second law of thermodynamics says that systems naturally lose usable energy over time. So in other words, you can't get something for nothing, at least not according to mainstream science or what we know so far. But let's just play devil's advocate for a moment. Gravity is constant, always there, always pulling. So could we design a system where gravity keeps the wheel turning forever? And that's exactly what some of the earliest inventors tried to do, and their thinking was pretty simple. If you could make a wheel where the weights were arranged just right, not evenly spaced from the centre, you could create a constant imbalance of torque that would keep a wheel spinning indefinitely. One of the most famous examples is Bhaskara's wheel, or the overbalanced wheel. This clever design used shifting weights, sometimes mercury and sealed tubes, that would move as the wheel turned, supposedly creating a never-ending push to keep it going. Now, on paper, it's genius. Just in reality, it didn't work. Every single design eventually lost speed and stopped, thanks to the unavoidable enemies of perpetual motion, friction, and air resistance. Gravity doesn't add new energy, it just moves things around. So without a way to replace the energy lost to the environment, the wheel inevitably comes to a halt. But here's the thing. These early attempts weren't pointless. They forced inventors and scientists to think critically about motion, energy, and efficiency, and they helped us cement the laws of thermodynamics that we use today. And while gravity alone couldn't crack the code, it inspired people to look again at natural forces that might. Which brings us to one that feels almost as mysterious: magnetism. Now, magnets are like a little bit of magic, nature's built-in cheat code. They can push or pull without touching, and when you first play with them, it's easy to imagine that you've found the key to endless motion. Over the years, inventors have tried arranging magnets in clever patterns to keep a rotator spinning. One classic approach is the magnetic rotor wheel, where magnets are positioned so that repelling forces keep kicking the wheel forward, and the dream is that the wheel just never stopped moving. But in reality, magnetic fields, like gravity, are what physicians call conservative forces. They can store and release energy, but they don't create new energy out of thin air. No matter how you arrange them, there's always a point in the rotation where the same forces that pushed you forward now pulls you back, and without extra energy to overcome that, the system just slows down. But that hasn't stopped people from experimenting. Some designs try and get around the pullback problem by adding shields, pieces of metal or a magnetic material that block or redirect a field at just the right time so that you feel the push and not the drag. Others use timed electromagnets, instead of permanent magnets, turning the field on and off, on when it's helpful and off when it would slow down the motion. Then there's the idea of using magnets not as the main power source, but as assistants. For example, magnetic bearings can hold a shaft in place with almost no contact, pretty much eliminating any friction. Halbach arrays, special arrangements of magnets, can focus a magnetic field on one side, making it stronger and more efficient for certain setups. Combining magnets with flywheels can store momentum for a long time, making a device feel pretty much perpetual, even though it's just running very, very efficiently. And of course, we can't forget magnetic levitation. Maglev systems, the moving parts floating above the track, which pretty much removes all mechanical resistance. Give a maglev rotor a push in a vacuum chamber and it can spin for an astonishing length of time. Not forever, but long enough that you'd start to wonder. So while magnets alone might never give us true perpetual motion, they can absolutely make systems much more efficient. And when you combine that with other natural forces, you start to get into the territory that feels just a little magical. In the modern era, engineers, tinkerers, and yes, even conspiracy theorists kept chasing this dream. Some use clever gear ratios, some use magnetic bearings, some even use electronics to pulse magnets at just the right moment to keep motion going. And while mainstream science says true perpetual motion is impossible, history is full of people proving impossible things end up sometimes being possible. So here's the real question. Even if we can't get infinite energy, can we get practically free energy? A system so efficient that it runs for years on tiny amounts of input. So you know what? Maybe perpetual motion, in its purest sense, is a dream, but the pursuit of it, using gravity, magnetism, or the forces of nature, pushes us to design better, think bigger, and maybe stumble across something revolutionary along the way. After all, almost every great invention started as an impossible idea. If you've got a theory, an experiment, or a design you're working on, please drop something in the comments. I'd love to see it. I'd love to see what you come up with and if you overcome any challenges that you previously thought might have been impossible. And if you enjoyed this little dive into the impossible, hit like, subscribe, and share it with someone who loves big ideas. And until the next time, keep questioning everything.